I mean my dog. Okay, everyone, welcome to this course, Fundamental Construction. Welcome to the course, and today we're going to be running some things and see the fundamentals of construction. Now, before we go far into this course, let's first of all ask ourselves, what is construction? What is construction? As we all can see from my screen, construction is constructing, altering, erecting, repairing, and demolishing building, civil engineering works, and other similar structures. It also contains assembly and installation on site of prefabricated components, building engineering services, building a house, repairing a road, demolishing dams, erecting bridges, etc. are examples of construction. Now we will look at it. There cannot be a construction without an industry that's piloting the construction, or without people doing those areas of construction. So those people doing that area of construction are the people we call the industries in charge of construction. The industries in charge of construction. So those are the people. Now let's look at construction industries. According to standard industrial classification definition, construction industry is the branch of manufacture and trade based on the building, maintaining, repairing, and repairing structures. And this includes drilling and solid mineral exploration. Now, I said according to standard industrial classification definition, construction is the branch of manufacture and trade based on the building, maintaining, and repairing structures. This includes drilling and exploration, mineral exploration. Now, we're going to be taking a break and we're going to be looking at elements of building construction. Now, when we talk of construction, we talk of building, but in this course for today, we're going to be hitting on building construction. Let's look at building construction. And before we go into that, I want us to think back, just take a deep breath and list some domestic construction companies in your state. List of domestic construction companies you know. I know if I want to ask someone, what are the construction companies you know? Somebody will tell me Julius Berger, RCC, EECC, whatever. There are so many construction companies in Nigeria which we know. So, but now and there are so many areas of construction. So we'll be looking at elements of building construction. Now, when we talk about the elements of building construction, first of all, look at in building, we have to talk about the planning. The planning. Planning is number one element, the planning. Planning. This is the elementary principle and basic requirements of a building planning layout of a residential buildings. Now, planning is the elementary principle, the basic requirement for building plan. So you have to plan the layout of a residential building. Then the two is by the time you plan, we'll be looking at the construction. And this is the classification of building based upon occupancy and structure. Now, construction, after you've planned, is now the classification of the building based upon occupancy and structure. Now, who are those that want to occupy the building you are constructing, or what is it going to be used for? That is what we mean by occupancy and the structure it takes. Now, the design, the load, common building components. Now, their function and nominal dimension, elements of building, drawing introduction, bylaw, etc. Now, let's go to our program so well. Now, the common building components you and I know, people know, is the basic building components we have. Now, under the basic building component, we have the superstructure and we have the substructure. We have the superstructure and also we have the substructure. Now, the superstructure is that part of building which is above the ground and which serves as the purpose of building's intended use. The superstructure is that purpose of the building which is above the ground and which serves the purpose of building intended use. Now, what we're saying here is that place we call the superstructure is the part of the building which is above the ground and all right. Now, welcome to the class. Today, we'll be looking at fundamentals of construction. The course, fundamentals of construction. That is what we'll be looking at in this course. And we'll be looking at what construction is and the construction industry. Now, take a step, look back. What construction industries do you know? And some of us could be working with some. Now, let's look at construction. Construction is constructing, altering, erecting, repairing, and demolishing buildings, civil engineering works, and other similar structures. It also contains assembly and installation on site of prefabricated components and building engineering services. Building a house, repairing a road, demolishing dams, erecting bridges, etc. These are all examples of constructions. These are all examples of construction. Now that brings us to this. Now when we talk about construction, now what is now construction industry? What do you understand by construction industry? It is the branch of manufacture and trade based on the building, maintaining, and repairing structures. This includes drilling, solid minerals, etc. This definition, according to industrial classification definition, construction industry is the branch of manufacture and trade based on the building, maintaining, and repairing structures. This includes drilling and solid minerals. This include drilling and solid minerals. Now let's take a look at the elements of construction. The elements of construction. So the elements of building construction. We'll be looking at the elements of building construction. So now you all agree with me that when you are building a house, automatically you are constructing a building. You are constructing a building. Now we'll be looking at the planning stage in the element of building construction. The planning stage, yeah, that's the elementary principles and basic requirements of building planning, the layout of a residential buildings. Now we'll also be looking at the construction, that the classification of building based upon occupancy and structure, design, load, common building components, and normal dimension, elements of building drawing, introduction to bylaws. Now the common building components, we have the basic building components. Now under the basic building components, as you can see from my screen, under the basic building components, we have the superstructure and we have the substructure. We have the superstructure and we have the substructure. Now the superstructure is that part of the building which is above the ground and which serves the purpose of building's intended use. Now what I mean by this is the superstructure of a building is that part of a building that is above the ground and also serve the purpose of the purpose to which or in which that building is constructed, or the purpose of the building's intended use, the purpose for which the building was constructed or to be used for. Now this includes the planes, the wall and the columns, the beams, the arches, the roofs and the slabs, the lintels and the arches, the chargers, the parapets, steps, and stairs. Now, for the substructure is the lower portion of the building. It is the lower portion of the building which is located below ground level, which transmits the load of the superstructure to the subsoil. Now, the substructure is the lower portion of the building which is below ground level and which transmits the load of the superstructure to the subsoil. And it includes the foundation. You agree with me that the foundation of every building is below the ground level, is below the ground level. So what the foundation does, it transmits the load from the superstructure to the subsoil. So it helps to take the load from the superstructure and releases it or empties it to the subsoil. So now we have, if you can see from my screen, the nominal dimension of building components. So we have the building components and we have the nominal dimensions. For the planes or the height, we have 30, 45, 60, 75, 90 centimeters. That is for the nominal dimensions. Then for the wall thickness, partition wall, loading, bearing walls, then we have 10 centimeters. 20 for the partition walls, 10 centimeters, the loading bearing walls, 20, 30 centimeters, to mention but a few. Now let's talk about the foundation. The basic function of foundation, is to transmit the load from building to the subsoil in such a way that settlements are within permissible limits. The basic function of foundation, the basic function of the foundation is to transmit the load from building to the subsoil in such a way that the settlements are within permissible limits. 2, the soil does not fail in shells. That is, it does not fail in shells, it does not go weak. 3, reduces the load intensity. 4, even distribution of load, equally distribution of load. 5, provide level surface. Now, I said the basic function of the foundation is to transmit the load to the load from the building to the subsoil in such a way that the settlements are within a permissible limit, that the soil does not fail in shell, and that it reduces the load intensity. Now, the loads are distributed evenly and provide level surface. Types of foundation. Now, the foundations might be broadly classified as shallow foundation, deep foundation, and we have two types of foundation. We have the shallow foundation, we have the deep foundation. The shallow foundation, we have the spread footing, the combined footing, the strap footing, the max foundation or raft foundation. So under the, we also have this, we also have the spread footing, the combined footing, the strap footing, the mat foundation, or the raft foundation. Now, the classification of foundation. I said we have the shallow foundation, the types of foundation. We have the deep foundation. Now, under the shallow foundation, we have the spread footing, the combined footing, the strap footing, the mat foundation, and the raft foundation. Please, let's take note of this. Now, the spread footings are those which spread the superimposed load of walls or columns over large areas. Spread footings are those which spread superimposed load of wall or columns over large area. Spread footings support either column or walls. Spread footings support either column or wall. Now, spread footing may be of the following kinds: single footing for column, stepped footing for column, sloped footing for column, wall footing without steps, and grillage foundation. So these you can see from my diagram here, you can see them illustrated here. Now, this is an example of the grillage foundation. This is an example of the grillage foundation. We have the iron, we have the column, this is the column, and this is the iron, and we have the steel beam, So you could see from here to here, this is the steel beam, which is also known as the grillage, and we have the concrete pad. Now, the combined footing is a spread footing which supports 3 or more columns, It's termed as combined footing. So the combined footing supports 3 or more columns. Now it has we have rectangular combined footing. Combined footings are of different kinds. We have the rectangular combined footing, we have the trapezoidal combined footing, we have the combined wall footing. We have these as the types of as different kinds of combined footing. So this is the trapezoidal footing. This is how it is, the trapezoidal footing. Then the strap footing. If an independent footing of 2 columns are connected by a beam, it is called a strap footing. Now, when an independent footing of 2 columns are connected by a beam, then it is called a strap footing. A strap footing may be used where distance between 2 columns is so great that the trapezoidal footing becomes quite narrow. So it is used in a place where the distance between 2 columns is so great that the trapezoidal footing becomes narrow. So the strap does not remain in contact with soil and does not transfer any pressure to the soil. So you could see this is a slab and this is a slab and beam, and You see what I mean here? My number 3 here is a strap type. This connecting this, and they are connecting this so that it does it because of the greatness. Now the Raft Foundation is a combined footing that covers the entire area beneath a structure and support all the wall column. The Raft Foundation is a combined building that covers the entire area beneath a structure and support all the walls and column. They are used in areas where the soil masses contains compressible lenses or the soil is sufficiently erratic so that differential settlement would be difficult to control. Now, the Raft Foundation are used in areas where the soil masses contains compressible lenses or the soil is sufficiently erratic so that the differential settlement would be difficult to control. So you can see what I mean by with my picture here. This is the flat plate. You can see the flat plate here, and this is the flat plate ticking under column. So this is my explanation, the Raft Foundation. Now you can see from the picture here, excuse me, you can see from the picture here what is going on. The Raft Foundation is going on. They are laying metals on the foundation, so making it a Raft Foundation. Now the deep foundation are of the following types: the pie foundation, the pie, the weir or caissons. They are the pie foundation, 2 the pie, 3 the weir or the caissons. Now, when we look at the pie foundation, is that type of foundation in which the loads are taken to a low level by means of vertical members, which may be timber, concrete, or steel. I said the pie foundation is the type of foundation in which the loads are taken to a low level by means of vertical members, which may be timber, concrete, or steel. Pie foundation may be adopted when no firm bearing strata is available and the load is uneven. We can adopt pie foundation when the load is uneven. Pie may be of the following types. We have the end-bearing pies, we have the friction pie, and we have the compact type. So the type of pies we have: the end-bearing pies, the friction pie, and the compact pie. These are the types of pie. This number 1 is the end-bearing pie. You could see there how it looks. Number 2 is the friction pie. The friction pie, and the third one is combination end-bearing and friction pie. So these are how they look. Now this continue here. Pie foundation. A pie foundation consists of cylindrical column of large diameter to support and transfer large superimposed load to the firm strata below. The pie foundation consists of cylindrical column of large diameter to support the transfer of large superimposed load to the firm strata below. Generally, pie foundation is shallow in depth than the pie foundation. Pie foundation is shallow in depth than the pie foundation. Now that takes us to the weir foundation. Weir foundation or caisson are bust-like structures which are sunk from the surface of either land or water to the desired depth. Now the weir foundation are bust-like structures which are sunk from the surface of either land or water to the desired depth. They are much larger than the pie foundation or drilled caisson Now the weir foundation are used for major foundation works like bridge piers, docks, large waterfront structure such as pump. I said the weir foundation or the caisson foundation are used for major foundation work like bridge piers, docks, large waterfront structures such as pump house. So you can see from my picture here, you can see the weir foundation, how it looks. This is the weir foundation. Now, the superstructure. The plinth is that part of the building between surrounding ground surface and floor space immediately above the ground or the ground level. Now, when we talk about the plinth, it is that part of the building between surrounding ground surface and floor space immediately above the ground level. Plinth resists the entry of rainwater entry inside the building. The plinth resists the entry of rainwater inside the building, entry of animal, insect, and rodent. General plinth height is 45, 60, 75, 90, or 120 cm, 120 centimeter. Now that brings me to the wall. Walls are building blocks of bricks or stones. They divide the building space into various spaces, into various rooms. They support slabs and beams. They safely transmit the loads coming on them from beam and slabs to the foundation. Now let's go over that. I said walls are building blocks of bricks or stones. They divide the building space into various rooms. So they divide the building space into various rooms. So there you have different rooms, this room for this room for that. So the walls does that. They support slabs and beams. The walls support the slabs and beams, and they safely transmit the loads coming on them from the beams and the slab to the foundation. So the load they receive, they safely transmit it to the foundation. They safely transmit it to the foundation without passing much stress. They provide privacy and precaution and protection against heat. They provide privacy and protection against heat, cold, rain, noise, dust winds. They offer resistance to firewall may be off. Now, what are we trying to say? The wall has several advantages they do in a building. One, they provide privacy. Two, they also bring protection against heat, cold, rain, noise, dust, winds. Now, and they also offer resistance to firewalls. They also offer resistance to firewalls. Now, this could be brick masonry and stone masonry. And this is an example of wall. So must have seen this so many times. Columns are vertical members along which beams and slabs is supported. They are square, rectangular, and circular in shape. Columns are vertical members along which beams and slabs or roofs is supported. They are square, rectangular, and circular in shape. Now, for the floor, a floor is a plain area to support occupants, furniture, and equipment. A floor is a plain area to support occupants, furniture, and space. Now, if you look at where you are now, you see that you are being supported by the floor of the building where you are sitting right now, because that is why it is what it's designed to do, to support the seat you are sitting. It supports the seat you are sitting. Now let's quickly take a look at the roof. The uppermost part of the building constitutes the roof. The uppermost part of the building constitutes the roof. The slab and the roof encloses the space and offers protection from rain, heat, snow, wind, sound, fire. Slabs are 10, 12, and or 15 centimeter. Slabs are 10, 12, or 15 centimeter. So this is an example of a column. It has different shapes and designs. This is an example of a column. Now this is the roof of the wall. This is a building, and if you see this building on my screen, we do not have roof on it yet. So it's just a building without a roof, so you can see how it looks. And this is the floor. This is the floor. See how the floor looks like. Now the doors and the window. A door provides a connecting link between rooms. A door provides a connecting link between rooms, or otherwise give access between rooms. Door provides connecting links between rooms, allowing easy free movement in the building. Windows are opening provided in walls. Windows are openings provided in walls. They are openings provided in walls. Doors and windows provide lighting and ventilation. The doors and the windows gives the room lighting and ventilation. They provide resistance to weather, sound, and heat. They provide security and privacy also. Now let's quickly look at the sizes of doors. For the residential area, the internal door is 0.9 by 2.0 meters. Now, and for external doors is 1.2 by 2 meters. And doors for bath and the toilet or the WC is 0.5 by 2.0 meters. Now, while for industrial buildings, the width is 1.5, 2.0, and 2.5 meters. The depth or height is 2.0 meters or 2.5 meters. We have different types of doors. So there are different types of doors. You can see that on my screen. The batten and the ledger door, the batten and the brace doors, the batten and the frame doors, the batten, ledger, and frame doors, frame and panel doors, the glazed doors, flush doors, louvers doors, wire gauge doors, etc., etc., etc. So this is an example of the batten and ledged door. This is how it looks on the screen. This is the batten and brace doors. So we could see that on the screen, and the batten, ledge, and frame doors. So these are how they look. Now this you've seen on my screen is the framed and paneled door. A framed and paneled door. It has a frame and a panel. It's a framed and a panel door. And this is the glazed door. This is the glazed door. This is the flush door. The flush door and the louvered door. And the revolving door, this is a revolving door. You must have seen this in some organizations, in some companies, or even in movies. It revolves. When you enter, it revolves. It's a revolving door. So we also have the sliding door. This is the sliding door. The sliding door. We have the collapsible steel door. Collapsible, you collapse it to open it. The collapsible steel door. We have the rolling shutter door. The rolling shutter door. From this picture, you must have seen these doors in one place or the other. Even some you must have seen them in shops, in businesses, or in business areas. Now we have the hollow metal door. The hollow metal door. This is an example of the hollow metal door. Now we also have the PVC door, which you see on the screen. We have the PVC door. Now the sizes of windows. The sizes of windows, we have 0.6, 0.75, 0.9, 1.0, 1.2, 1.5, 1.8 meters. And the depth, we have 0.6, 0.75, etc. The sizes of ventilation width, we have 0.3, 0.45, 0.6, etc. Now for the types of window, we have fixed, we have pivoted, we have double hung, sliding, casement, sash, louvered, metal, bail, etc. And this is an example of pivoted window. It's an example of pivoted windows. This is double hung window, and this is slide window. This is slide window. Most of the buildings we live today has this kind of window. This is casement window. This is casement window, and this is the sash window and louvered window. We also have bay window, which you're seeing right now on my screen, the dormer window, the gable windows, the skylight windows, the lantern windows, corner windows, sills. Sills are lower portion of windows and ventilator opening. Sills are lower portion of windows and ventilation opening. Now from my screen, you can see the sill here. The sill here, this is the sill. This is the apron of a window. This is the apron of a window. This is the sill of the window. The steps and stairs. Steps and stairs are meant to provide access between different levels. stairs should be properly located to provide easy access and fast service to the building. The stairs should be properly located to provide easy access and fast service to the building. Now, in one flight, maximum 8 steps should be provided for more than 8 steps. For more than 8 steps, it is recommended to provide them with landing. Generally, for residential building, width of stairs is 1.0 meters to or 1.2 meters. Number of risers, total height of floor, height of risers, total height of floor all over or stroke the height of risers. Number of tread, number of risers minus 1. So this is example of steps and step. Step terminologies. The beam. Beams are horizontal members above which the slabs are provided. The beams are instead supported on walls and columns. They are generally 20, 39, 45, 60 centimeter thick and deep members as per structure design. So this is beam. The lintel and the arch. Lintel is a horizontal member which is placed across the opening. An arch is normally a curved member comprising of wedge-shaped building blocks holding each other with mutual pressure. The chargers are provided on external walls, wall opening to get protection from rain, snow, and heat. They are weather shield. Their thickness tapers from 100 to 75 millimeters, and projection is 30 to 90 centimeter or 30, 45 etc. The parrot is generally 10-meter thick partition wall constructed above slab to enclose the terrace opening to sky. Thickness is 10 to 15 centimeter height, and it's 10 to 15 centimeter. The height is 1.0 meters to 1.2 meters. Different types of buildings. Now, buildings are classified based on its occupancy and structures. Buildings are classified based on the occupancy and structures. Buildings are, we have residential buildings for types of building. We have educational building, institutional building, assembly building, business buildings, merchandise buildings, industrial building, storage buildings, then hazardous building. Now, the residential building is a building in which sleeping arrangements are provided with or without cooking arrangement. It includes single or multi family dwelling apartment, lodging, restaurant, hotels, dormitories, and hotels. Educational building, it includes buildings used for school, college, education purpose. Institutional buildings are buildings used for different purposes such as medical or other treatment. They include hospitals, auditorium, jails, or asylum. Assembly buildings, these are the buildings or where a group of people meet or gather for amusement, social, religious, political, civil, travel, and similar purposes. Now, example of this is the theater, the moon picture houses, assembly halls, restaurant, assembly halls. Now, business building. These buildings are used for transactions of businesses, for keeping accounts and for similar other purposes. The mercantile building are buildings used as shops, stores, markets for display and sales of merchandise, entire wholesale or retail, office, shop, storage services. Then we also have the industrial buildings. Now, the buildings where products or materials of all kinds and properties are fabricated, assembled, manufactured, or processed. Then the storage buildings. Now, these are used primarily for the storage of shelter of goods and these are ware or merchandise, vehicles or animal grains. Then the hazardous buildings are used for the storage, handling, manufacturing, or processing of highly combustible or explosive materials or products. Classification based on structure. Classification based on structure. Now, the load-bearing structure, the frame structure. Now, for the load-bearing structure, in this type of structure, loads from roof slab or trusses and floors are transmitted through walls to the firm soil below the ground. These type of structures are adopted where hard structures are available at shallow depth. The structural elements like beam, slab rest directly, like beam slabs rest directly on the walls. Now we also talk about the frame structure. The reinforced cement concrete structures are the most common type of construction today. They consist of skeletons of beams and columns. The load is transferred from beam to the columns and columns to and from the columns it then transferred the load directly to the subsoil through footing. Frame structures are suitable for multi-story buildings subjected to a variety of extreme loads like compressive, tensile torsion, shear along with moments. The open space in the skeletons are to be filled with brick walls or glass panels. So we could see that now types of loads. Now the various types of load include the dead load, the life load, wind load, earthquake load, and erection load. Now the dead load comprises of the weight of all walls, partitions, floors, and roofs, including all permanent construction in the building. On the other hand, the wind load is considered as basic wind pressure, in which is equivalent static pressure in the direction of the wind. Wind pressure always act in the vertically exposed surface of the walls and columns. The snow load, actual load due to snow, depends upon the shape of the roof and its capacity to retain the snow. The load due to snow may be assumed to be 2.5 kg per meter cube per centimeter depth of snow. The earthquake load produced wave in every possible direction below ground as per intensity or scale of the earthquake. The life load consists of moving or